Hello class 12th. In the last lecture, we have discussed about the refraction and its equation. Today, we will discuss about the principle of reversibility, the lateral shift, and the refraction through multiple media. And our first topic is principle of reversibility. So that defines that refractive index of one medium with respect to second is reciprocal the refractive index of second medium with respect to one. So talking about the principle of reversibility of light, for this let's draw our ray diagram. Let this line is separating the two media like medium 1 and medium 2, and the light is coming from medium 1. So now taking this medium as a rarer medium and this medium 2 as a denser medium, so when the light will enter in the medium 2, it will deviate towards the normal like this, and making the angle of incidence with the name I and the angle of refraction with the name small r. Using the Snell's law for these two intervening media, we can write sin I by sin r is equal to the refractive index of the medium 2 with respect to medium 1. So mention it, that is 1 and 2. And suppose the light is reflecting at the same angle. How? Using a plane mirror, if the light is falling, the refracted ray is falling exactly at 90 degree between this, exactly at right angle. So what will happen? So the light will retrace its path. It will go back. So the light is retracing its path after the reflection from this mirror. Say this mirror is M1, M2, not necessary to mention it. So light is going from medium 2 to medium 1 now, medium 2 to medium 1. In this case, when the light is going from medium 2 to medium 1, in this situation, the angle of incidence becomes R. Mention it. When the light is going from medium 2 to medium 1, so this becomes angle of incidence and this one becomes angle of refraction. Now, writing the Snell's law for when light is going from medium 2 to medium 1. As the light is going from this medium, so angle of incidence was R. So sine of angle of incidence, symbol is R. With the sine of angle of refraction, the symbol R. So what we will write the refractive index, that was N. When the light was moving from medium 1 to 2, we have written 1 and 2. And now the light is moving from 2 to 1. So we will write 2 and 1. Making these as equation 1 and this one as equation 2. And just multiply the equation 1 with equation number 2. On multiplying the left hand side, sin I by sin r into sin r by sin I. And in the right hand side, 1 and 2 into 2 and 1. So what you can see, the sin r is cancelled with the sin r and sin I is cancelled with the sin 1. So this is cancelled with each other and we will get only 1. So on cancelling, we are getting 1 is equal to 1 and 2 with 2 and 1. Or we can say, on taking this 1 and 2 in this side, 1 upon 1 and 2 is equal to 2 and 1. This was what? Exactly the principle of reversibility, which was stating that the refractive index of medium 2, with respect to medium 1, is reciprocal of, to whose reciprocal it is? It is the reciprocal of refractive index of medium 1. See, the refractive index of medium 1 with respect to medium 2, this one. Or we can also say, suppose the two media, first one is air and the second one is glass. So A and G means refractive index of glass with respect to air will be equal to what? 1 over GNA means refractive index of air with respect to refractive index of glass. This is exactly what the principle of reversibility. Or numerically, if A and G is equal to 3 by 2, then G and A means refractive index of air with respect to glass will be 2 by 3. See the reciprocal of that. This completes the principle of reversibility. Now our new topic is lateral displacement or lateral shift. In class 10th, we have seen this topic, but how to calculate this shift? Let's see. Taking a glass slab again, and the incident ray is falling on it. The normal, the refracted ray, the angle of incidence, the angle of refraction. Till this we have seen in the last video, but we are going to calculate the lateral shift. So what is the definition of lateral shift? First of all, the definition of the lateral shift or lateral displacement. It is defined as the perpendicular displacement or the perpendicular shift between the original path of the incident ray and the emergent path of the light. In class 10 we have discussed about this, but in this topic we are going to calculate that perpendicular shift. So as the definition says, the perpendicular distance between the original incident ray and the emergent ray. So let's draw the original path and the emergent path of the ray. The original path of the ray, and you can see the now refracted ray is again going to change the medium. So again the refraction phenomena will happen. So let's draw first perpendicular here, then the light will deviate away from its normal because it's coming from denser to rarer medium. So this is the emergent ray, because incident ray, refracted ray, and the emergent ray. This is the original path. So the perpendicular distance between these two is called the lateral shift. We are going to calculate this one. So I have named these as incident ray with the AB, refracted ray BC, the emergent ray CD, the glass slab PQRS, the first normal MN, second normal as only C, and mentioning this angle. What would be this? Sorry, one more thing. This perpendicular shift that we are going to calculate, let this is M. No, sorry, M it is second. Let this is L, because L for lateral shift we can say. So this is lateral shift CL. We are going to calculate this. So this normal and this normal are parallel to each other. So according to the alternate angle, so this R angle, this one will be equal to this angle R, and this one as the emergent ray. So this one is the angle of emergence. Now since we know that the angle of incidence, the angle of emergence both are equal, as we are saying that perpendicular shift means both the lines are parallel to each other. So this angle E is equal to angle E, and let this angle is theta, because we are going to calculate, I have taken this one as L, this distance, this perpendicular shift CL. So we can use here the sine of angle of this one. So on writing this here in the triangle BCL, mention it in the triangle BCL. So in this triangle BCL, sine theta is equal to perpendicular CL, and the hypotenuse BC, sine theta is equal to CL upon BC. Now CL is equal to BC sine theta, means we can calculate the CL. This is the perpendicular shift, but this sine theta, what is this? The angle is unknown. For that we can see here the angle of incidence. This one is a straight line and this one is a straight line making X. So we can say R plus theta and the angle I are equal, means that is I is equal to R plus theta. Again see that they are making vertical opposite angle, this one and this one as X. So this angle I will be equal to R plus theta, as we have written here, angle I is equal to R plus theta. So angle theta is equal to angle I minus angle R. So we can put it here in this equation. CL is equal to what we will get on putting the value. CL is equal to BC sine I minus R. But still, we can measure the angle of I, the angle of incidence. What about the angle, sorry, what about the value of BC? Because this will be inside the glass slab. So for that, we have to replace the BC. What I'm going to do, in the triangle, this one, BNC, in this triangle, BNC. See here, in this triangle, cos R, means see here again, cos R, what says? Base upon hypotenuse. So it becomes BN upon BC. BN upon BC. Or BC is equal to BN upon cos R. Or again, cos R is sec R. So BC is equal to sec R into BN. So we can use this BC. Let's put the value of BC in this equation, and what we will get, see here, this was the equation. On putting the value of BC, that was sec R into BN sine I minus R. This BN, just see here, the B and the N, this is what? The thickness of glass slab. Let the thickness of the glass slab was T. Now finally, on summing up this equation, what we will get, this Vn is the thickness of the glass slab into sine I minus R and into sec R. This is what CL, this was what? The shift, perpendicular shift. Now we can calculate the perpendicular shift with this equation. We have seen the refraction between two media, the light coming from one medium and going through second medium and emerges out from the medium. Now suppose if there are more than two media, means if there are three media, four media, or 1,000 of media are there, if the light is going through that mediums, then so what will be the relation between them? For that, let's see. For that, the refraction through multiple media, I'm taking the three media. One is air, second one is water, third one is glass, but I'm writing in general study. So as 1, 2, 3. So here it is. The first medium I'm taking air, from which the light is coming. Second medium I'm taking water, and third medium as a glass. But in starting I'm naming it 1, 2, 3 only. I will name it like medium 1, medium 2, medium 3. So what will happen next? Let's draw. Now see, the first light is coming from air to water. It bent toward the normal because in between water is denser, air is rarer. So when the light enter in the denser medium, so light will bend toward the normal. So this is the angle of incidence I, and the angle of refraction I am naming R1. Now again the light is going from water to glass. Again the refraction will happen. See how? Now the light has entered in the glass from water. So from water it is coming toward the glass. Again in between water and glass is denser, so it will bend toward the normal again. And see here, this normal and this normal are parallel to each other. So this angle R1 will be equal to this angle because of the alternate property. So this one will be R1 and this one will be different. So I'm naming it as R2. Again see, the light is going to enter in air. So again the refraction phenomena will happen, but now the light is going from denser medium to rarer medium, and we know that when the light emerges from any multiple medium or any single medium, it becomes parallel to the original path. So this ray, emergent ray, will be parallel to this original path. Now, so the incident ray and the emergent ray are parallel to each other. So we can write that this angle E is equal to angle I. And what about this angle? Again, this normal and this normal are parallel to each other. So R2 and this angle will be R2 again. Now we will write the Snell's law for air, water, then water, glass, and then glass to air. Let's write for the first medium, when the light is going from air to water using the Snell's law, sine I by sine R1 will be equal to 1 and 2. Let's write it here. What I have written, air to water, when the light going through this, air to water, sine I, sine R1, sine I, sine R1 is equal to 1 and 2. Now the light is going from medium 2 to medium 3, means from water to glass. Let's write the Snell's law again. See here, light is going from 2 to 3. The angle of incidence is here R1, angle of refraction is here R2. So sine of angle of incidence R1, sine of angle of refraction R2 is equal to 2 and 3, because it is going from medium 2 to medium 3. Now the light is going from glass to air. Now the light is going from glass to air. This is glass, this is air. In the glass, angle of incidence is R2, and in the air, the angle of refraction is E, which is equal to angle I. So I'm writing only I here. So we can see here the sine of angle of incidence R2 and the sine of angle of refraction, here emergence angle, that is equal to I. So sine R2 upon sine I is equal to 3 and 1, because light is going from 3 to 1. So we can say here, this is equation 1, this is equation 2, and this is equation 3. As we have done in the principle of reversibility topic, let's multiply the equation 1, 2 and 3 together. On multiplying all, we get sine I by sine R1 into this and this and this again. See here, the sine I in the numerator, the sine I in the denominator, sine R1 in the numerator, sine R1 is the denominator. Again, sine R2 in the numerator and the sine R2 in the denominator, means all will cancel, gives 1 only. Let's write that. So what you obtain, this is 1, 1 and 2, 2 and 3, 3 and 1. And if I'm naming it as 1 for air, 2 for water and 3 for glass, what will we here see here? So on naming them, it becomes A and W, W and G, G and A. So here is the equation for the relation between the refractive indices of 3 media, 1 and 2, 2 and 3, 3 and 1. So the point how to write this equation if there are more than 3 media. So first of all, let's see how to write for these 3 media. Just draw a circle like this. In that circle, mention these arrows 1 to 2, 2 to 3 and 3 to 1, and match it. That 1 to 2, see 1 to 2, then 2 to 3, then 2 to 3, and then 3 to 1, 3 and 1 comes to 1 only. So whatever be the number of media, the product of every medium, the product of the refractive indices of every medium is equal to 1. If there are 4 media, then follow the same. Draw circle, put numbers, then 1 and 2, 2 and 3, 3 and 4, 4 and 1. So how to write? Like this for 4 media. 1 and 2, 2 and 3, 3 and 4, and 4 and 1. Suppose if there are 4 or 5 media, then what you will write? 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 1. Just follow this circle. For this, let's take an example of numerical. Suppose if A and G, means refractive index of glass is with respect to air is 3 by 2, refractive index of water with respect to air is 4 by 3, and refractive index of glass with respect to water to calculate. First of all, write the general equation A and W, W and G, G and A. You can change the sequence also, but the cycle must be continuing, means you can change A and G, G and W and A. You can change it, but the cycle must complete. A and G is well known, this one. W and G we have to calculate, but G and A we don't know. Here it is given A and G. So we know that by the principle of reversibility, G and A can be written as 1 upon A and G, like this. And on filling the values, A and W is 4 by 3, W and G we have to calculate, and A and G value is 3 by 2. See here. On further calculating, W and G is equal to 3 by 2 cross 3 by 4. On solving, we got W and G, that is 9 by 8. So we have got the refractive index of glass with respect to water, 9 by 8. Why we are doing this? Because every refractive index is called absolute refractive index if it is not given anything. Means suppose it is written that refractive index of glass is 3 by 2. So whenever we are talking that the refractive index of glass, that with respect to air is already understood. is not given in the word, but you have to take that respect is air. But if it is written that refractive index of glass with respect to water spatially, then we have to calculate, we must follow these ways. Okay, so we have seen when there are multiple of media, and then at that time we have the relation. Remember that cycle. If there are three media, write 1, 2, 3, 4, then write 1, 2, 3, 4, and come to straight the same point. So if there are thousand of medias there, then we will write 1 and 2, 2 and 3, 3 and 4, and dot dot dot, triple 99, triple nine to 1000, and then 1000 n to 1. We can calculate to any refractive index of any media given at least, means suppose there are n medias, so you must be having the refractive indices of n minus 1 media, then you can calculate the last one. And we have seen one numerical also. And so till then, for that next video,